Welcome to 4Keys Private Tuition. So this one is a follow-up video on the first video that I did on Schmitt triggers. Hopefully this one will make you understand it better. If you need more information, you can contact me directly. Go to my YouTube channel, 4Keys College. Subscribe. I'll be doing a series. Hopefully, eventually you catch up. Okay, so on the previous video, we're looking at this. I think this is where I need to start off. So what influences the output voltage from a Schmitt trigger is your input voltage, your feedback voltage, and also the difference between the input voltage and the feedback voltage. So maybe we need to look at each of these separately. We can look at input voltage, we can look at feedback voltage, and we can also look at the difference, the VD. So all these are going to have a bearing on the output voltage. So it depends on which one you want to look at, depending on your objective in explaining the output voltage. Okay, so here let me take you to the input voltage. So the input voltage, so let's imagine you have an upper threshold and a lower threshold to this input voltage. And as you shall see, you set this using your feedback loop. So it is the one that determines the upper threshold and the lower threshold. The feedback of voltage really sets for you the upper threshold and the lower threshold. We'll look at that using numbers. But anyway, for now, I want you to imagine that your input voltage is lower than your upper threshold. So what's going to happen is that we're going to have a VD that is positive. How is that possible? So if you look at that equation, I want you to check out this equation here. So inside that bracket, we have a positive voltage minus your negative voltage. So the negative voltage is your input voltage. The positive voltage there is your feedback voltage. So I want you to imagine VF minus your V in. So this is what we are saying. So let's hold this constant, and let's say this V in is less than this number. So obviously, if it's less, we're going to have a positive. So our VD is going to be positive, and we are going to go to positive saturation. So this is what happens for the Schmitt trigger to go to positive saturation. Now, if V in is now larger, if we increase this number above VF, above our upper threshold, then what we're going to do is we're going to have a negative value from that bracket, and that's going to cause our Schmitt trigger to go down to negative saturation. So it's really these differences that determine polarity. So when your V in is less than the upper threshold, then VD is going to be positive, and your output voltage is going to be positive. And when your V in is greater than the upper threshold, now your V in suddenly is above the upper threshold. What's going to happen is that the difference is going to be now negative, and the Schmitt trigger goes down to your negative saturation. Now, when it's down there, how do we trigger it up? So we are now referring to a new threshold, which is our lower threshold. So for as long as V in is greater than the lower threshold, then our VD will remain negative, and the Schmitt trigger will remain at that negative saturation. But when our V in is now less than the lower threshold, then we are back to a VD which is positive, and we go back to positive saturation. So this is what's happening. We are saying here our VF versus the input voltage. So why is it that we're saying feedback voltage? You need to understand that feedback voltage is equal to the upper threshold when we are at positive saturation. So your feedback voltage is equal to the upper threshold, and at negative saturation, your feedback voltage is equal to the lower threshold. So it is this feedback voltage and that really sets for you the upper threshold and the lower threshold. Let's look at numbers. Let's use specific numbers. So let's imagine here on that diagram you have a 10k a 10 kilo ohm resistor, a 10k for R1, and also a 10k for R2. And let's imagine that here you have an output voltage of 10 volts. So if you wanted to calculate your VF would be equal to, which is this feedback voltage, will be equal. So let's imagine this is our positive saturation. This is the maximum value for your output voltage, which is your positive VSAT. So it's 10V, and negative VSAT is negative 10V. So here we are saying we're at positive saturation. So what is the feedback voltage at positive saturation? So it would be equal to your, remember we said that our V out, so it would be 10V times your R1, which is a 10K over 10K plus 10K, which would be a 10 over 20, that's a 0.5 times your 10V, that gives you a VF of 5 volts. So we are saying at positive saturation, our upper threshold voltage is equal to 5 volts. So this is what it means. When we say that our VF has to be equal to the upper threshold for us to achieve positive saturation. So our upper threshold is 5V. That also means that our lower threshold in this case becomes minus 5V. So we have set our upper threshold and lower threshold by just using that voltage divider rule there. Okay, so with that in mind, I want to look at this graph here. So let's look at this graph here. So you have now set your upper threshold and your lower threshold. So at this positive saturation, we say that our upper threshold is plus 5 volts, and here minus 5. So we want to look at the behavior of V in, and this would be your VF. This plus 5 minus 5, that's your VF. So VF can take this value, a maximum of plus 5 and a minimum of minus 5 if you want. That's another way to look at it. So we are saying for as long as our VF is at this value plus 5, then we are going to be at positive saturation. But as soon as, now this is your V in, right? As soon as your V in and your feedback voltage meet here, that's fine. But as soon as we go above that plus 5 cap, what's going to happen is that the VD is going to be negative, and immediately we go to negative saturation. And this VF also goes down to minus 5. So VF is now at minus 5, and now we are down there. For as long as it's at minus 5 there, that's fine. But if we hit an input voltage such that that input voltage now starts to fall below minus 5, what's going to happen is that our VD is going to be positive, and this one goes back up. Okay, and this cycle continues on and on and on. Hopefully it makes sense. So this is the relationship between your VF, your VD, and your output voltage when it comes to saturation. So you saw that here we're at plus 10, which is your VSAT, your positive VSAT, and at minus 10, which is your negative VSAT. So hopefully it makes things clear. Those are the relationships that I thought were not clear in the previous video. If you want more information, you can always contact me directly. You can always join my WhatsApp classes so that we explain this even further. So see you in the next video.